Okay, good morning. Okay, good morning, grade 10s. Hope you are having a wonderful day so far. I know it's only about lesson 3 of the day, but hope it's been great so far. Okay, it's cold outside, but I hope we're keeping warm, and let's get ready for today's lesson. Okay, so last week we did the atmosphere. Okay, we looked at what the atmosphere is, why it's important, and the structure. Okay, can anyone remember the different layers? Going from lowest to highest. Anyone? Yes, Matt, that is correct. So there we go. We looked at was the troposphere, that is the atmosphere in which we live in. Okay, it's got all the different gases and elements that we need to survive, for ecosystems to thrive, and for our environment to thrive. Okay, we then have our stratosphere, different gases which help absorb, collect, and whatnot. Okay, we have our mesosphere. Okay, and then our thermosphere. Alright, okay, each layer serves a purpose. Right, okay, so when we look up into space, we look up into the blue sky, we know that that is our atmosphere. Okay, alright, so we got this down. Okay, so again, the definition is, yes, Carl. Okay, yeah, the layer of gas that surround Earth. Okay, very easy. Composition of the atmosphere, we got our solids. Okay, dust particles, salt crystals, liquids, water and form of clouds, our water vapor, okay, evaporation, gases, obviously we've got different gases, nitrogen, oxygen, argon, carbon dioxide, all of those that are present. Alright, okay. So we looked at this, we looked at close to the Earth is our troposphere, contains the gas which are essential for life, as I said, contains the weather, very important. Okay, contains a layer of ozone, absorb ultraviolet rays. Okay, dream is very cold, prevents dust and rocks from space. Okay, furthest away it's got our satellites, absorbs harmful X-rays and ultraviolet rays. Alright, importance of the atmosphere, anyone? If you just want to read, you're more than welcome to. Yes. Yes, well, okay. Awesome, yeah, okay, so it protects us from harmful ultraviolet rays, as I said. Okay, contains gases, water vapor for clouds, rain and moisture, very important for life on Earth. Without rain, without weather, we will most likely all die. Okay, weather takes place in the atmosphere. Okay, now we looked at, here it says, if we look at layer 2, the stratosphere. Okay, it's got a layer of ozone. Okay, ozone absorbs the ultraviolet rays, UV, from the sun. Okay, so ozone layer is a gas. Okay, obviously, it's made up of 3 molecules of oxygen. Okay, there we see O3. Ozone layer protects the Earth as it absorbs ultraviolet rays. Okay, some of the rays that come in from the sun are too harmful for us. Okay, it's too dangerous. So these gases absorb them and protect us. Okay, now obviously as humans we use deodorants and we produce a lot of emissions from manufacturing. Okay, using fossil fuels and all of that from cars. So CFCs is a big one, aerosol refrigerators, they all release CFCs. Ozone layer becomes thinner, which means that less of those ultraviolet rays are going to be absorbed, ultimately resulting in more of those rays coming in, meaning more detrimental effects on us. Okay, so we look at more skin cancer, more sunburn, eye cataracts, weakens the body immune system. Okay, those ultraviolet rays are not good for us. Okay, but we've been to this. Okay, okay, so now today's lesson we are looking at heating of the atmosphere. Okay, so let's rule off today's date, heating of the atmosphere. Okay, so what elements, okay, obviously you can see this diagram, okay, so obviously what's the main contributor towards heating of the earth? Okay, it's this big guy here, okay, the sun. The sun is the main reason for our warm days or our cold nights or whatnot. Okay, so we look at Earth's greenhouse effect. Let's take that down. So heading Earth's greenhouse effect. Okay, so we can see here greenhouse gases let the sun's shortwave radiation, visible light, so the light we see from the sun coming in from space, okay, reach the earth but trap some of the long wave infrared or heat radiation coming from the warm earth. Okay, so that short wave comes in, hits the earth, okay, it's then reflected off, or it's radiated off as a long wave. So there it's short, then it's long, okay, then it's trapped by the gases in our atmosphere. It's either reflected, stays in, it's absorbed, okay, or the ground itself absorbs that heat. Okay. Okay, so processes of heating, okay, so radiation, emission of heat and energy in the form of waves. Okay, so now obviously we see here 51% is absorbed by surfaces, so concrete, tar, buildings, steel, metal, so forth, all in our urbanized areas. Even in our rural areas, the ground absorbs, tin sheeting, all of that, all absorbs water, even the ocean absorbs the heat. Okay, so then we look now our long wave, okay, the clouds, the water vapor, the different molecules, all of that also scatter, absorb that heat. Okay, so you see reflected by atmosphere 6%, reflected by cloud 20%, and reflected from surfaces 4%. Okay, 19% absorbed by atmosphere and clouds. Okay, so this is looking at when that short wave, so the sun's rays come in, okay, the atmosphere gets rid of some, the clouds, and then obviously some surfaces because it reflects it off. Okay, then vice versa, as that long wave comes up off the earth, that heat that is radiated, the water vapor and different molecules absorb that heat. Right, okay, let's take down this diagram. I think it's very important. It just shows us nicely what's happening and how that radiation is absorbed and how those short waves, the sun's light coming in or heat, is lost in the atmosphere or reflected. Okay. Are there any questions so far regarding this? I think it's quite straightforward, we can understand. Okay. Alright, moving on to the next slide. Okay, this shows us conduction and convection. So conduction, not conduction is. Yes, Chris? It is the transfer of heat by contact. Okay, brilliant. Yeah, it is the transfer of heat by contact. So if I touch something, okay, it's going to get hot. Okay, convection, the transfer of heat by vertical movement. Okay, so if you heat something up, the molecules will expand and they will rise. Okay, they will go vertical because as air is heated, it rises. Okay, due to its expansion. So you can see here, if you touch something, you're conducting that heat. Okay, convection. You can see as it heats it up, it's going up like this. Okay, this will form part of types of rainfall. You get convection rainfall, which is heating the Earth's surface. That air mass above the Earth is then heated. The molecules expand, it rises, condenses, obviously. Okay, then rains. The radiation, the heat is radiated from the plate. Okay, it's just a simple diagram to show us. Okay, let's take that down quickly. Okay, moving on. Okay, insolation versus terrestrial radiation. Okay, so anyone know what insolation is or what it stands for? No one? Okay, so insolation, we look at the in, stands for incoming. Okay, sol is the incoming solar, and then radiation. Okay, so incoming is the sun's rays, the sun's energy. Okay, incoming is solar, the sun, and then radiation. Okay, so radiating off the earth. Okay, that heat that is trapped is radiated. Okay, so take down these notes while discuss it. Okay, so radiation that comes from the sun in the form of waves. So as I said, short wave coming in, okay, and then it is radiated off as long wave radiation. Okay, it usually happens during the day when radiant heat is transferred. Okay, so obviously during the day we have the sun. Okay, we need that sun's energy during the day for this process to happen. Okay, in the form of long and short wave, primarily heats the Earth's surface. Okay, so another key thing that we need to realize is that the Earth is heated from the ground to the top. Okay, that heat coming in does not heat the atmosphere on its way down. Okay, it is only heated from the Earth. So the sun heats the Earth, and then from there it heats the atmosphere going up. Okay, not from the sun going in, not from the sun's energy coming in. Okay, so obviously now we heat the Earth. Okay, it's radiated off, heats up that our atmosphere. Okay, let's take that down. Give you a few seconds. Okay, any questions? If there are any misconceptions in terms of short wave and long wave, okay, short wave, because the sun's energy is intense, it's coming in quickly, okay, but then obviously when it hits the Earth, it heats up that Earth, okay, it's longer, okay, it's less hectic, okay, it's more calm the way it comes off, okay, it's more passive. Alright, okay, so now that we got that, we can look at terrestrial radiation. Okay, so that's radiation that comes from the Earth and its atmosphere, so it's not due to the sun. Okay, so now this usually happens during nighttime. Okay, obviously now we've heated up our atmosphere, we've heated up surfaces, we've heated up molecules, water vapor, all of that. Now that it's stored. Okay, now the sun goes away, nighttime, that heat is then radiated. Okay, it is then released. Okay, so mostly happens at night, consists of long waves, okay, because it's a slow, gradual process, long waves, okay. Water vapor and carbon dioxide are concentrated close to Earth, whereas more absorption takes place and the air is warmer, okay. Okay, so I'll give you a few seconds to take that down. So obviously, looking at heating of the atmosphere, these two, insolation, terrestrial radiation, all coming from the sun's energy. Okay, any questions so far? None? Okay, awesome. Okay, I hope you've all got that down. Okay, so the next, this looks like convection, conduction, and radiation. Just another simple diagram with heat and pot, water. Okay, now the next chapter or the next section we look at factors that affect temperature. Thank you.